Hello everyone and welcome to the fifth problem in the Pan-African Maths Olympiad 2021. And the problem goes like this. Find all functional equations mapping from R to R such that for all x and y members of real numbers, this following equation holds. So first of all, we're going to go through the solution now. So usually a standard way of writing functional equation solutions are, we say let P of x, y, let it be the assertion, like the statement in our question. So just write the same thing again. Okay, so the reason why we go with this is because it had to be easier to plug in numbers. Instead of like saying x equals 0, y equals 0, just write the values we plug in inside this. So it's much more convenient. So a good way of starting functional equation problems is to plug in both x and y as 0. So when we do that, we get this. Now P of 0, 0 gives us f of 0 squared is equals to f of 0 plus f of 0 plus 2 f of 0. So that will be 4f of 0. So this gives us this. And from here, we can conclude that f of 0 minus 4 is equals to 0. So f of 0 is equals to 0 or 4. So this leaves us with two cases. So the first case we are going to consider now is when f of 0 is when f of 0 takes value of 0. So the first case, case 1. So f of 0 is 0. So when f of 0 is 0, if you notice, this is our first step. We plugged in both values to be 0. So now let's plug in only one of the values to be 0. And because this function is symmetric, it doesn't really matter which variable we plug in as 0. It will give us the same thing. So let's plug in y equals to 0. So this will give us this. So this gives f of x, xf of x is equals to what? F of x squared. So this is a nice property of this functional equation, that f of x squared is equals to xf of x. So then similarly from here, we can also get that yf of x, yf of y is equals to f of y squared. So this is just like x and y are just placeholders. So if you swap the variables, then obviously same functional equation properties to go. So from these two facts now, what we can do from here now is we can substitute f of x squared, f of y squared for this and this respectively on this right hand side of the equation. And the reason why we do that is because we'll notice that some things may cancel out when we expand the left hand side. So let's go through it and see what we get. So let's substitute f of x squared for xf of x and f of y squared for yf of y and see what it gives us. So when we do that, substituting, we get f of x plus y, x plus f of y is equals to xf of x plus yf of y plus 2f xy, 2x of xy, yeah. So yeah, if we are observant, we see that this and this can be obtained by multiplying this and this and this and this. So it would be a good idea to expand this left hand side, and yeah, some things we cancel out. So let's expand this left hand side and see what we get. So when we do that, we get xf of x plus yf of y. I'm already rearranging it. I'm not writing it in the order I got them. So this is what we're going to get. It's equals to what? Then the right hand side, we write this. Okay. So from here, as I said earlier on, this can go out with this. This can also go with this. So what are we going to be left with? We're going to be left with xy plus f of x, f of y is equals to f of xy. So this is also another interesting functional equation, another interesting property of this question. So let's write it at the center here and see what we get. Remember, this is true for all x and y member of real numbers, because that's what this is the domain and range that the function is defined on. So from this point now, we can plug in y equals to any number. Because yeah, I want to plug in y equals to or x equals to any, like this function is symmetric. So yeah, we just have to select one variable and see what we plug in. So one plug in y equals to any number, let's say t, then we'll be left with only f of x and t. So, but like to make this function to give us the best possible substitution, we have to like try to make sure we have only x and f of x left. So a good value of t would be like when we have to look into this place here, xy. So we make t to be equals to 1, this and this will both be f of x. So that would be the best possible value. So any other value except 1 will make this f of xy to be different from f of x. So the best value of y we can plug in is y equals to 1. We could also plug in y equals to 0, but if we plug in y equals to 0, we are going to get something trivial. We are going to get 0 is equals to 0, and we already know that, so it's nothing new. So that's why we plug in y equals to 1. So when we plug in y equals to 1, what does it give us? We get x plus f of x, f of 1. Remember, I don't know what the value of f of 1 is, so just leave it that way. It's equals to 2 f of x. So this is what we have. Okay. So so as at this point now, we can make f of x the subject of formula. And when we do that, we get something else. But we can actually go on this question like this. We can also plug in x equals to 1. So when we plug in x equals to 1, we can try to find the value of f of 1. So we get 1 plus f of 1 squared is equals to 2f of 1. So this can be rearranged. This is a perfect square. This is what we get. So f of 1 can take only value of 1. So f of 1 is 1. So now that I know f of 1 is 1, we can further simplify this equation we have here. So when plug in f of 1 equals 1 in this equation, what do we get? We get x plus f of x is equals to 2f of x. So making f of x subject of formula, I'll get f of x equals to x. So f of x equals to x, under this case, f of 0 equals 0. Remember, I'll still have another case to consider, but in the case f of 0 equals 0, get f of x equals x. So let's check, and we have to make sure we plug in this, what we got here, into our original functional equation. So what we got here just means that if there's to be any solution to this functional equation, it has to be this thing. But it does not necessarily mean this is a solution to the functional equation. But more often than not, yeah, this is a solution. But to be 100% sure, we have to test it back into our original equation. So let's go back to our original equation. This is our original equation. And we're like trying to test in f of x plus x. Let's just do it quickly here. So this will be x plus y. The x plus y also. This will be x squared plus y squared plus 2f xy. I'll know that this identity is true. This is the expansion of this. So in this case, when we plugged it in, we saw that it actually holds. So f of x equals x is a solution. And it's the only solution under this case, f of 0 equals 0. We are done on this first case. So let's go to the second case now. Case 2. F of 0 is equals to 4. So let me write down our question now. Remember, this was our question. So we are going to do something very similar as we did in our earlier case. Just that here we get some different numbers. So what we're going to do, we're going to plug in y equals to 0 and leave x as it is. So this gives us what? 4 plus x. Let me write it in the order I got it. F of x, x plus 4 is equals to 4, because f of x squared. We have to be careful in this because in this case here, it's not looking so natural. But here, the first case, you could have, many of us may have guessed that, yeah, this would be a solution. But this case, it's not so clear what we guess may be a solution here. So we have to be careful. So this will be plus f of 0 squared is still 0. So that will be 4 plus 2f of 0. That will be 8. Right, yeah. So this is 12. Let's just clean it to 12. So we have this. So can still try to make f of x squared the subject of formula, because we want to substitute this f of x squared. Is difficult to work with it directly. So we are trying to find something f of x squared in terms of some other simpler values. And we like values like this, something that have f of x times x, because on this left-hand side of the equation, we can get things like that. So everything is going to be similar to this first case, because at the end, in the long run, we're still going to expand the left-hand side and hopefully some things cancel out. So that's what we're going to. We're going to try to make f of x squared subject formula here. All that give us f of x squared equals to xf of x plus 4 f of x minus 12. Then similarly, we can always swap the variables. They are just placeholders. So this is what we have for this. So what we're going to do, we're going to substitute this and this. We're going to substitute it in the right-hand side of this equation here. This is our original question. This is p of x, y. And our original question. So we're going to substitute here and see what we get. So when we do that, get this. So as I said earlier on, the first case and the second case are very similar. Just that we have to be very careful in the second case because right now it's difficult to guess what a function that can work. So you just have to be careful and do everything. Be very careful in our algebra because we cannot really trace well. It's harder to trace mistakes when we cannot guess a function that works. So that's why we have to be much more careful. So from this point, we get x f of x plus 4 f of x minus 12 plus y f of y plus 4 f of y minus 12 plus 2 f of xy. So this is what we have. Then now we can expand this left hand side again. So we can cancel out x f of x and y f of y. So let's do that. So we're going to get x f of x plus y f of y plus xy plus f of x f of y is equals to what? X f of x plus y f of y. I'm rearranging the terms. I'm not really writing it in the order that they occurred here, but I believe to be easy to trace and see that both equations are equivalent. So this 12, I'll combine it together to get 24, and we'll be left with plus 2f of xy. So we can cancel this out with this. We can cancel this out with this. So it's a little bit simpler now. So what do we have now? We have xy plus f of x, f of y is equals to 4f of x plus 4f of y minus 24 plus 2f of xy. So as at this point now, we can do something very similar to what we did in our first case. We can plug in y equals to 1. When we plug in y equals to 1, we'll get an equation involving only f of x and x. So we can make and some constants. So we can make f of x to be a subject of formula, and we get f of x in terms of f of 1, x, and some constants. But as we saw earlier on, we can actually try to find the possible values of f of 1 first of all. So after we plug in x equals to y equals to 1, we find the possible values of f of 1. And after that, we'll plug in only y equals 1. So as at that point, we already know what values f of 1 can take. So if it uses much of the unknown constants, so that's why it's going to be a good idea to plug in x, y equals to 1, x equals to y equals to 1. Is at this point. So we can try to find the values of f of 1. So if plug in x equals y equals 1, what do we get? We'll get 1 plus f of 1 squared is equals to 4f of 1 plus 4f of 1. That's 8f of 1 minus 24 plus 2f of 1. So this is what we have, right? Okay, so rearranging this, we get f of 1 squared plus 1 is equals to 10f of 1 minus 24. So carrying everything to one side, we get f of 1 squared minus 10f of 1 plus 25 is equals to 0. So those of us familiar with quadratic equation can notice that this is a perfect square. So it implies that what f of 1 is 5. So f of 1 is 5. So now that I found the value of f of 1, we can plug in just y equals to 1. So when plug in y equals to 1, remember in this equation here, this is where we're plugging in. When plugging y equals to 1, what do we get? We get x plus 5f of x is equals to what? 4f of x plus 20, because f of 1 is 5. 4 times 5, that is 20, minus 24 plus what? 2f of x. So we can make f of x the subject formula here. So it has, as you see, we have found the value of f of 1. If we hadn't found the value of f of 1, this equation will have here will be involving f of 1 here, and it has at that point to be an unknown constant, but now it's a known constant, so that's why I'll just plug this in directly. So simplifying, we get x plus f of x is equals to, the like terms here are 6f of x minus 4. Hope we didn't make any mistake, because yes, I said it's harder to trace mistakes because and it's more difficult to get something that works here. So let's try and verify. F of x is 20. So I think everything is good to go. So carry this to this side, and when we simplify, we get f of x equals to what? X plus 4. So this is what we have. F of x equals x plus 4. So after all our solving in this second case, when f of 0 is 0, we get f of x equals x plus 4. So what do we do next? We have to plug in. We have to, so as I said earlier on, this functional equation arrived at does not necessarily mean it satisfies our original functional equation. It just means that if there's to be any functional equation that satisfies our original functional equation, it has to be this. The solutions to our original functional equation is a subset of what we get at the end of our solving. So we have to plug in this. We have to plug this into our original functional equation here. So let me write the original functional equation again. It's a lot of times. Remember, I'm plugging it into the original one, not all these other properties we got around. Like we have to plug it into the very first question that we are given, the question we are given, the exact question we are given. That's what we have to plug it into. So as at this point now, when we plug in f of x for x plus 4, let's see what we get. So this bracket becomes x plus y plus 4. The second bracket still becomes the same thing. It equals to what? X squared plus 4 plus y squared plus 4. So at this point, we're not sure they're equal, so we can put question mark. Plus 2 xy plus 4. So this left-hand side is x plus y plus 4 all squared. So is it equals to x squared plus y squared plus 2xy plus 16. So are these two things equal? Of course, they are not equal. Why? Because this expansion on the left-hand side, it actually has all these terms here, but it has some extra terms, that is 8x plus 8y. So these two numbers are not equal. So, okay, so this identity is not true. So a way we can actually do this is to try and find some special values of x and y we can plug into where both sides of the equations are not the same. So we can plug in, what can we plug into? Simply this. So we can plug in probably y equals to minus 4 and x equals to 0. So when we plug in y equals minus 4 and x equals 0, x plus y plus 4 will be what? 0. So it will be 0 squared. While this side here will be what? This will be 0, this will be 16, this will be 0, this will be 16, this side will be 32. So as you can see, for when x is 0 and y is minus 4, both sides are not equal. Because actually it's not an identity, so it cannot hold for all x and y. So as we see now, this functional equation got in the case when f of 0 is equal to 4 does not actually satisfy our original equation, so we don't count it. It's not part of it. So it's wrong. So the only functional equation, therefore, the only solution is the solution we got in our first case, f of x equals x for all x member of real numbers. This is the only solution to this functional equation. So this was just a standard problem. We just had to usually it's a good idea to start plugging 0, 0 when we see functional equations of this form. And also, like as you saw at the ending part, we got a functional equation here which looked legit. Why? Because f of 1 was 5, f of 0 was 4. Two of them actually satisfied it. So it looked legit, but when we plug it into our original question, so that it didn't actually work. So it's always a good practice to always, at the end of the day, when we are done solving a functional equation, to always plug it back to verify if actually satisfies our original equation. We have to do that. It's very, very, very necessary. As we saw, like this looked legit, but in the long run, it didn't satisfy our original functional equation. So this is just all I'll have for today, and I'll see you some other time. Thanks for joining.